Let's dive straight into today's diagnostic report. What we're doing here is an acoustic and linguistic forensic evaluation of the provided script audio. We are strictly looking at the hard data to objectively assess the mechanics of intelligibility. We're going to see exactly how specific phonetic and prosodic errors don't just give someone an accent, but fundamentally alter the very meaning of the words being spoken. We're breaking this report down into 5 rigid areas. We'll start with a macro-level overall score, and then drill down into phonetic symbols, critical words, word stress, and finally, sentence stress. Okay, Section 1, the overall score, which gives us our baseline intelligibility assessment. Let's look at the unfiltered verdict. The overall score sits at a 32 out of 100. To put that scale into perspective, a native speaker's pronunciation is exactly 100, and a baseline CEFR A2 level is a 10. So while this audio clears the basic A2 threshold, it falls way short of functional professional fluency. We are officially categorizing this as a significant intelligibility breakdown. The density of phonetic and structural errors is just so high that the intended meaning is often entirely lost, or worse, completely transformed. It causes a total semantic breakdown. Moving to Section 2, phonetic symbols. Let's look at the foundational micro-level mechanics that dragged that overall score down. We have some critical priority errors here that literally changed the meaning of the script. First up, the ah vowel sound. In the target word flaw, a serious error in lip rounding and tongue placement shifted this into an O sound, making it sound exactly like flow. Think about that. A security flaw is a massive problem, but a security flow sounds like a normal IT process. It completely changes the sentence. Similarly, missing the A sound turned the word raise into rise. Plus, the airflow on the th sound was totally blocked, turning it into a hard stop consonant. These aren't just stylistic quirks, they are physical substitution errors that destroy comprehension. Compounding those critical issues are some secondary priority problems. There's a really noticeable lack of rhoticity, that R coloring, making words like rogue, regulators, and broader sound incredibly weak. On top of that, the schwa, that relaxed neutral vowel sound, is over-articulated. In a word like autonomous, instead of relaxing the vowels, the speaker sounded out every single letter. It makes the speech here very rigid and choppy. When you combine these secondary errors with those critical substitutions we just talked about, overall intelligibility absolutely plummets. Section 3. Critical words. Let's see how those phonetic failures manifested in the top 10 pronunciation failures from the script. Before we look at the whole list, we have to talk about a literal 0-point catastrophic failure. The speaker attempted the phrase Claude Opus 4 model attempted, but what was actually recorded was a single, unintelligible non-word that sounded something like cruised. The entire complex noun phrase was just completely lost. In a professional discussion about advanced AI, missing the core technical subject entirely severs the listener's ability to follow along. So, looking at the top 5 critical errors, that 0-point collapse is obviously sitting at number 1. Right behind it, at 2 and 3, are those phoneme substitutions we discussed, flaw becoming flow and raise becoming rise. At numbers 4 and 5, we have crucial context words. Mythos was distorted by vowel errors into something unrecognizable, and anthropic was mangled by both a missing TH consonant and totally incorrect stress, making the company name impossible to catch. If you can't clearly articulate major models or corporate names, you immediately lose credibility with your audience. Rounding out the top 10, we see how failing to reduce vowels ruined longer words. Autonomous, at number 6, is a textbook example of this stiffness. Internationally, lacked elision, meaning the speaker didn't naturally drop sounds the way native speakers do. So the syllables weren't compressed. It sounded flat and robotic. And for a word like unpredictable, the weak transitions between consonant clusters basically dissolved the word's cohesion. The result? The listener has to burn a ton of cognitive energy just trying to stitch individual syllables back together. Section 4, word stress. Let's talk about rhythm and polysyllabic emphasis. Here are the top 5 word stress failures. English is a stress-timed language. If you don't nail the primary stress, the word just won't be recognized. The target stress for autonomous is on the second syllable, but the data shows the speaker put equal weight on every single syllable, completely neutralizing the required rhythm. With anthropic, placing the primary stress mistakenly on the first syllable muddied the actual target vowel.
And treating compound words like capabilities flatly or hitting the second stress in cybersecurity way too hard just destroys the natural musicality of the language. Finally, Section 5, Sentence Stress. This looks at the broader syntactic flow and intonation across complete thoughts.
Looking at the top 3 sentence stress failures, we start with the Claude Opus 4 model segment. Because that subject phrase was rushed and distorted into a non-word, it completely destroyed the grammatical anchor of the sentence. The listener had no subject to connect the verb to. Second, look at the list structure. Discovered a security flaw, accessed the internet, and hacked. When listing items, you need a rising intonation and specific stress peaks, which were entirely missing here. Plus, swapping flaw for flow totally derailed the syntactic stress. Lastly, mispronouncing raise as rise threw off the pacing of the entire final clause, meaning crucial nouns and adjectives like serious, global, and experts didn't get the operational stress they needed to land effectively. Which brings us to the final verdict, and it's a stark one. These mechanical errors fundamentally alter the semantic meaning of the script. When you're dealing with advanced tech fields like autonomous AI agents or cybersecurity, pronunciation precision isn't just about sounding pretty, it's a physical requirement for transmitting accurate data. A tiny vowel shift from flaw to flow or the complete collapse of a noun phrase completely derails professional communication. After analyzing this acoustic data, one major question emerges. If the machines we are discussing are highly precise, shouldn't the language we use to control and regulate them be exactly as precise? This diagnostic proves just how easily mechanical voice errors can completely rewrite the facts of your message.